Vanakkam. I was explaining about unit cell in the previous sessions. Unit cell is a fundamental repeating portion of a crystalline solid. Basic understanding of a unit cell is very much essential to know the crystalline structure. So let me repeat the definition for a unit cell. Unit cell is the basic, fundamental, repeating structural unit of a crystalline solid. What does it mean? A crystalline solid means it consists of, is made up of millions and millions of a unit cell. So this is the fundamental smallest portion. If you understand the structure or arrangement of the atoms or molecules in the unit cell, we can very well understand the crystalline structure. So unit cell is a very important part. So we have to know about the arrangement of the atoms in the unit cell. The arrangement of the atoms in the unit cell can be imagined as a structure or a geometry. So to know about the geometry or structure of an unit cell, I told you we need two parameters. One is the edge length, and another is the interfacial angle. Hope you remember. Let me repeat, no problem. So in a crystal, we have millions and millions of atoms. We have to assume in 3 dimension. 3 dimension means you have to assume in the left, right, top, bottom, front and back. So let me assume one atom at the crystal, at the center of the crystal. You can consider another adjacent atom in the x-axis, and next another adjacent atom in the y-axis, and the next adjacent atom in the z-axis. If you could be able to find out that distance between these two atoms, so let me repeat, the distance between these two atoms in the x-axis, in the y-axis, in the z-axis, it is the edge length. Edge length is this. So next one is the interfacial angle. If we could be able to find out the angle between atoms in x and y axis, y and z axis, z and x axis, these are called interfacial angle. By measuring these two parameters, we can know, we can imagine a particular geometry to the unit cell. Crystallographers who analyze the structure of crystals are called crystallographers. Identify different types of unit cells which differ in the edge length and the angle. The unit cells are classified into 2 types. Yesterday itself I told you, one is primitive and another is non-primitive. What is the difference? Primitive unit cell means we have atoms. Atoms can be considered as lattice points. Only one type of atoms. Atoms are present in one kind of lattice point only, means it is called a primitive. I will explain you later. So say if in a geometry, if atoms are present only at the corners, it is called a primitive unit cell. Along with the corner atoms, along with the corner position, if atoms are present in additional lattice points can be face center or at the body center. I will explain you later. If additional lattice points are present along with the corners, it is called a non-primitive. There are 2 types, primitive and non-primitive unit cells. Crystallographers identified 7 types of primitive unit cells. 7 types. They are called, yesterday I told you, cubic unit cell. Second is tetragonal unit cell. Third is hexagonal unit cell. Fourth is rhombic unit cell. Just try to know the names. Next is monoclinic. And next is a triclinic. 1, 2, 3, 4, 5, 6. The last is rhombohedral. But in our unit, we are going to concentrate only on the clinic. Anyway, these 7 primitive unit cells differ, remember, in the edge length and in the angle. What about non-primitive? Bravis identified 14 crystal system. So this cubic has 2 other non-primitive. What is it? See, let me illustrate. So let me consider a cubic shape. This is only imaginary, a cubic arrangement. If atoms are present at the 8 corners. So these are called the corner atoms. This is cubic shape. This is cubic. Atoms are present only at the corners. So this is primitive. If an atom is present at the body center, So this is present, I will show you again with a model. So now consider at the center. So this atom is present at the center of these 4 atoms at the bottom and these 4 atoms at the top. This is called the body center. So this is an additional point along with the corners. So this one is primitive, simple cubic. If an atom is present in an additional point like at the body center, it comes under non-primitive. See, there is one more non-primitive in the cubic. So this is again simple cubic, primitive. So you can assume phases. So this cube has 6 faces. Can you identify? See the face. This is a face at the top. This is the second face at the bottom. This is the third face in the left side. This is the 4th face present in the right side. Top, bottom, left, right. What are the 2 other faces? Yes. So this is the face present behind, present at the back. This is the face present at the front. So we have 6 faces. If an atom is present in between these 4 atoms, so this is called an atom at the face center. This is an additional point. So one more atom, the face at the bottom. One more atom, face in the right side. One more atom, face center of the left face. One more atom, the face present behind, back side. This is 1. And face present in the front. So we have 6 additional atoms at the 6 faces. This is non-primitive. So this is non-primitive. Yes. So see, this is primitive having atoms only at the corners. If additional points are present, it is called a non-primitive. So there are 7 primitive unit cells. In the primitive unit cells, additional points if present, they are called a non-primitive. Bravius identified 14 crystal structures. I will show you in a picture. So unit cell, 14 types of unit cells, including primitive and non-primitive. So I will explain you with a chart.